Hello. Hi, everybody. Is anybody there yet? Let me see if I remember how to share my screen while I'm waiting. Hello. I'm going to log in this way. Waiting. Let me know when you guys are here, okay? You. Waiting for you on the Hangout. Hello. Anybody there? Let's see what these are. Hello. I don't know what that means. Special item. Oh, okay, maybe I close that one now. Okay. Question and answer. Data capture. Cameraman. What's a cameraman? Oh, cam. Sort of. Okay. Charlie. That off. No. Hello. Huh. Oh, hi, Dennis. I see. Are you here? Dennis. Let's see. Do this. Screen share. Dennis. Your mic on. I cannot hear you. Dennis? Hello? Oh, hi, Dennis. I am waiting for Arjun. Gina also said she's coming. Hi, Dennis. There you are. How are you?
I'm good. How are you?
Good, thanks. Can you hear me okay? I could barely hear you.
I could hear you okay.
Okay, you might want to turn up your mic a little bit more. Or your, I don't know if your mic or your speakers. We'll start shortly because I know Arjun said he was on the phone with his mom. Meanwhile, did you get a chance? Now, the handout that I gave you, you probably couldn't print it, right?
I didn't try to print
That's
it
okay.
today.
Do me a favor.
Yeah.
How many computers do you have? While we're waiting for our June, do you have one or two computers? Is there a device you can do this on, and then another computer that you can open up the handout?
I can do that. Yeah.
Yes?
Yes, I could do that.
That might be
Yeah.
beneficial, or and maybe not. We'll just get started, and let me see. I'm gonna see how I'm gonna share my screen with you, and hopefully then others can join. I'm sure Arjun will say when he's there. I'll just let's try this, so you don't have to do that, okay? I'm gonna share my whole screen with you, okay? So I'll open the handout, but my handout also has answers on there, okay? But you won't be able to see the answers because you'll see why. You have a notebook with you to take notes on, right?
Yep.
Do you have a excuse me? Do you have a periodic table with you too?
Yeah.
Okay. So let me
Yeah.
open. Oh, hide. Hold on one second. All right. Can you see my screen, honey?
Yeah.
Okay. So here's the very first question that appears on the sheet. Hang on one second. My daughter's calling. So try not to look at the first answer box because that's as far as I can scroll down. Hang on one second. Hi, honey.
Okay.
Go ahead and try to write the net equation for the first reaction, and we'll talk about it together. Give me one moment. Hi, honey, Rena. No, I told you I didn't have school, honey. I'm online, though. I'm online with my students. We're doing a Google Hangout, okay? I know. We'll talk in a minute when I'm done at 1. What about... He's ready, but I'm upstairs, honey. I'm online with my students. I can't go downstairs. I love you. I'll call you when I'm done at 1. Bye. Okay, sorry about that. Okay, are you ready? So when we're writing a net ionic equation, Dennis, and I can't write on this, I don't think. Let me see if I have any text marking tools. First, we want to start with the hydrobromic acid. See that? Right there?
Yeah.
Okay, and you want to write its formula on your paper. Okay?
Okay.
And then you also want to write the next formula on your paper, lithium hydroxide. Okay?
Okay.
But then you want to label them as strong acid or weak acid and strong base or weak base. So what is hydrobromic acid?
A strong acid.
Yes, so label it SA for strong acid, okay? And
Okay.
then LiOH, that is a
Strong base.
strong base, okay? All right, and then, hold on, basically I see your screen, but I can't join the Hangout for some reason. Okay, hold on, I think I'm going to have to close the screen and go back and get Arjun. So hang on one second. So you go ahead and finish that one. The next part you're going to have to do is calculate the moles of each. So do you have, while I'm letting Arjun in, do you have go get your other computer so you can pull up the worksheet?
Okay.
You're going to open it up through the Google Plus community, okay?
Okay.
All right, let me get Arjun here, because Arjun can't get in, so I'm going to stop my screen sharing, and I'm going to go see if I can get Arjun. I'm going to re-invite Arjun. And go ahead. Do you have your other computer yet?
Yeah.
Okay. So go ahead and complete that. What you need to do is calculate each. Hold on. I sent you another invitation just now. I'm sending him an email on my phone. Go ahead and calculate the moles of each, and then you have the actual, from the net ionic equation. I'll just keep talking while we're waiting for him. What's going to react out of H and Br, and what's going to react out of Li and OH?
OH is going to react with the H plus and HBr, and Br is going to react with the lithium.
Okay, let's talk about that. Thank you. So definitely yes, H plus will react with OH minus to make water, right? So write that on your paper first. And then we're going to talk about what you talked about with lithium and bromine, okay?
Okay.
So first write the, oh, I think I see Arjun.
Hello.
Hi, Arjun. Yeah, when I was screen sharing, I guess when I was screen sharing with Dennis, then it was hard to let you back in. So I just sent you a new invite. Perfect.
All right, that sounds good.
Okay, so really quick, did you not print out the handout at all? If not, that's okay.
Yeah, I got it.
Oh, you're
I
awesome.
printed it
Thank
out.
you. Did you get a
Yep.
chance? Thank you for showing me. You're cool. Did you get a chance to start the like your headphones too?
Yeah.
I would
Thank you.
mine, but when I play it back, oh my gosh, I'm so loud on the headphones. So you can hear me okay, right?
Yeah, I hear you fine.
Okay, cool. So you didn't get a chance to start the first problem yet, right?
No, I'm
Dennis and
on
I.
number 5, actually.
Awesome.
I went
Okay,
through a difficult yet.
so we can talk about, as soon as Dennis gets caught up, we'll talk about number 1, and then we'll talk about the rest and get you caught up through 5. So while we're waiting for Dennis to finish up here, or actually Dennis, we're going to join you back, and then I'm going to actually, Arjun, be showing you the solutions page while we talk about the problems, okay?
Okay.
So I'm going to share my screen with you in a moment. Let me just catch up with Dennis. Hey, Dennis.
That sounds good. Well,
Hi. Okay, so you know how we
Hi.
said, so first let's have Arjun tell me his net ionic equation for number 1 that you and I just talked about, Dennis, okay? All right, Dennis, Arjun, what do you have for the first net ionic equation?
So the first ionic equation is just going to be H plus OH equals H2O, or the arrows H2O.
Can you read that with all the charges for me, please?
Oh, yeah.
You like to read off some of your charges. I remember that. By the way, are you guys staying nice and warm?
Yeah, actually, my house is nice and warm, so that's good.
Good. Awesome. Okay, so go ahead, read it again, Arjun, the net ionic equation.
Yep, so it's H plus plus OH minus,
Yep.
and then the forward-backward arrows equals H2O.
Very nice. Now, Dennis and I were just talking about it when I was having him predict the products. He also told me, and let's discuss that together, that Li plus Br minus would form LiBr. Dennis, did you write that on your paper, and so we can discuss it?
I wrote it on my paper.
Okay. Yeah. So will that happen? This is what I'm talking about. So I won't be able to. I'm writing it in the chat box. I won't be able to. I'm going to switch screens in a minute. So will this reaction actually happen? Let's talk about that. Because you told me, Dennis, that Li plus would combine with Br minus, that would form LiBr. Is that true when we're talking about net ionic equations? Will that form?
No.
Because what do we know about lithium?
No, not necessarily.
Go ahead. Sorry?
It's going to be aqueous in solution.
Right. Lithium bromide is aqueous, always appears as aqueous ions in solution. So lithium bromide will not form because lithium's always what? Soluble, right?
Yep.
Do you agree, Dennis?
Yeah.
Okay. So the only net ionic equation you're going to get is the H plus OH minus yield water. Now I'm going to screen share so I could go back to the answer key, okay, for you guys? So give me a moment. Okay. I'm going to share my screen with you. To everyone. Okay, hide. And okay, here it is. Can you guys see my screen now?
Yep.
Yep. Yeah. Okay. So this is just an example of a titration problem, yes? So Dennis, yes. Did you get a chance to calculate the moles in excess?
Yeah.
Great. Did you calculate the pH at all yet, Dennis?
Yeah.
Okay, what'd you get for your pH?
I think I got 12.36.
Okay, great. Or about 12.36 and 12.38. Is that what you got too, Arjun?
No. I tried using the molarities because I assumed they diffuse completely in solution because they were both strong acids and strong bases. And then I subtracted molarities and did.
You can't subtract molarities, sweetie. You can only subtract moles.
Right, yeah, that's where I screwed up, but that's fine. I understand where to go after that.
Okay, do you see the solution on the screen now, Dennis, Arjun? So yeah, you can only subtract moles, not molarities, okay?
Okay.
Because otherwise, if you took 1 molar HCl in theory and added 1 molar HCl according to what you did, you would get 2 molar HCl, which is not true.
Right. Yeah.
Molarities are not additive, okay?
Okay, that makes sense.
Thank you. And I answered your question about your question you asked, and Dennis, in case you didn't know, if we have school tomorrow's just the solubility quiz, okay?
All right.
And then we probably won't have the big test till like Monday.
Okay.
Okay? All right, here, next question. Ready, guys? Number 2. Whoops, I don't see the answer. So they're mixing hydroiodic acid. Okay, I'm going to highlight that. Is hydroiodic acid strong or weak, you guys?
Strong.
You agree? Dennis, strong. Now they're mixing it with how many bases, though?
2.
2 bases. So what do we need to do here? We need to calculate or approximate the moles of each. So let's try to approximate it. Can't speak. Approximate it, okay? So for example, if we approximate, how many moles of hydrochloric acid are there, you guys? Approximately. Without a calculator. Can you guys, what would you do with 210 milliliters to make it an easier number to work with to calculate moles? In your head, you guys can make 210 milliliters into? 0.2, right?
Yep.
So what's 0.2 times 0.1?
0.002.
0.2 times 0.1 is how many zeros?
2 zeros.
Is it 2 zeros or 1 zeros, you guys?
1 0.
It's 1 0. Right?
Yep.
Dennis? 0.2 times 0.1, because if you do it by hand, you get 2, and you move the decimal place 2 to the left, right?
Yep.
0.02? Dennis?
I guess so. Yeah.
Well, write it on paper, honey. I don't want you to guess so, okay? 0.2 times 0.1, do it on your paper without a calculator, okay? So then you would multiply the way they teach it. I think I remember when we did this in grade school was 2 times 1, then you get 2, correct?
Yeah.
Now the decimal place is behind the 2 on the right, yes? How many places do you move it to the left? You move it how many to the left? 2 to the left, because in each number there is 1 decimal place, correct? Yes?
Yeah.
So that's why you move the decimal place 2 places to the left, and you get 0.02 and not 0.002. Okay?
Okay.
Similarly, then, how many moles of sodium hydroxide are there, you guys?
0.01.
Excellent. Do you agree, Dennis? 0.1 times 0.1 gives you 0.01? Yes? Yes or no?
Yeah.
Okay. Now, 50 milliliters is about what?
About 0.005.
0.05.
Yep.
0.05 times 0.3. And you can go ahead and write this on your paper, Dennis. You don't have to do it all in your head, okay? Both of you can do it in your head. What's 0.03 times 0.05 times 0.3? We're approximating again. This is not exactly. And you could always do it, you know, if you wanted exactly with your pen. So, okay. What did you get? So overall, we're just trying to find out, because we want to know if the pH is less than, greater than, or equal 7. We want to know if the moles are equal or if there's more than one than the other, right?
Mm-hmm.
Yes? So they'll ask you this, and maybe they'll ask you this on the multiple choice, the non-calculator section of the exam. So you get that it's about, what do you get? 0.05 times 0.3 is about 0.015, yes?
Yeah, yeah.
And then we said it also had 0.01 from the sodium hydroxide.
Yep.
So that would give you about 0.025. Do we agree?
Yep.
So all we need to know here, Dennis, I want to make sure I'm not losing you, which is there more of, the hydroxide ion or the hydrogen ion?
And the hydroxide.
Right. So therefore the answer would be what?
Greater than 7.
Greater than 7. Dennis, do you follow?
Yeah.
Okay. Let's go to number 3. Okay. We're combining acetic acid and sodium and potassium hydroxide and identifying the species with the highest concentrations of equilibrium, okay? And they're equal volumes, okay? So take a moment to do that. I know Arjun's already finished it, so bear with us, Arjun, for a sec, okay? Arjun, if you like, you can work ahead, okay?
Okay.
And then I can zip you the, well, I don't know if I can actually give you the answers. I could check your answers if you want to tell them to me, you know, during the session, or you can email them to me later.
That sounds good.
I can't send you the answers because you have to have, well, I could try, but I think you need a digital encryption code that only I can get for the answers.
Okay.
Sorry. All right, go ahead. Dennis, you're writing, yes?
Yeah.
And Arjun, you're working ahead, right?
Yep.
Cool. La 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 la. Think we're gonna have school tomorrow?
Yeah.
I don't know, because it isn't supposed to be as cold, but it's supposed to snow tonight, so I don't know if that becomes a factor.
Yeah, I think they base it off the wind chill mostly, and of course how much snow and when it falls, you know?
Yeah. They might just have no school tomorrow only because it's still going to be like -20 wind chill in the morning.
Is it?
But yeah.
Yeah. Well, you want to know the funny thing? They canceled my daughter's. No, they called yesterday and said my daughter would have late start at Palatine High School,
Okay.
and they were all so mad. But then they called at 5 this morning to say school was canceled.
That's annoying.
I know, because the kids are sleeping. They don't know.
Yeah. And you still have to wake up. Like usually when that happens to me, I still end up waking up at 6.
Yeah. Okay. You guys almost ready? Dennis, are you ready?
I guess.
Okay, let's try. What do you start? Read me your equation that you have so far.
HC2H3O2 plus KLA. I did not get that equation.
Okay, let's talk. Okay, so you started again with HC2H3O2, correct?
Yeah.
Yes? Why did you keep it together? Who do we keep together? Is that a weak acid or a strong acid?
A weak.
Right, so it's a weak acid, so we keep it together. Do you agree, Arjun?
Yep.
All right, cool. Then, potassium hydroxide, Dennis, is that a strong base or a weak base, honey?
Strong.
Strong, okay. So who is going to react on potassium hydroxide? Is it going to be potassium or hydroxide?
Hydroxide.
Very good. So we're only going to write down the hydroxide ion, okay? Yes, do you agree?
Yep.
Yeah, I agree. Yeah.
Yep. Okay, so Arjun, you want to read me the products that you have, and then we'll explain it to Dennis, okay?
Yeah. I actually wrote down the wrong reaction, but the products from the equation you had, yeah, the products from the equation you had should just be like the counter ion of the weak acid, right? So it should be HC2 H3O2.
Wait, that's the formula of the acid.
Right.
Yes.
So when you combine it with OH, don't you form the other counter ion of the acid?
What the formula is, honey, because you can't write counter ion on your paper. You've got to write the reaction. So what's that going to be? Well, think it very simply, you guys. What's hydroxide going to react with in acetic acid?
DH. So
DH
it's going
plus.
to be.
Do you agree, Dennis?
Yeah.
And then, so what's one of the products must be?
C2H3O2.
No. If the hydroxide reacts
yeah.
from acetic acid, what's one of the products must be?
Water.
Water. Do you agree, Dennis?
Yeah.
Okay, then go ahead, Arjun. What must be the other product, honey?
C2H3O2.
Is there a charge? You don't like charges.
Minus. Yeah, my bad. -1.
I'm going to charge you. No. Okay, here we go. So this is what we just said. Okay? Can you see the bottom of my screen, you guys?
Yep.
All right. It says acetic acid plus OH minus. There we go. We see the H plus is pulled off, so it has to have a charge because we removed the H plus, so the negative ion is left. Okay? Dennis, do you agree?
Yeah.
We should have written these kind of reactions already in our acid-base unit, correct?
Yeah.
Notice the product of an acid and a base is water, plus you'll get the anion here, okay? Yes or no?
Yes.
All right, so if they're equal volumes, Dennis, are you done writing it down? Arjun, are you finished writing it down?
Yeah.
Yep.
Yes? Okay, so if you have equal volumes and they have the same... Oh, she can hear you and see you, but I'm not a part of the Hangout. Okay, great. I'm going to re-invite Gina in a second, so hang on. Hold on. I'll re-invite you. Hold on. I just got an email from her. Invite you now. Sorry. Keep working ahead. Let me invite her, and we'll go back to this question, okay? So now you've got to predict which one of these has the highest ion concentrations, okay? Make sure. Okay, so here we go. I'm going to close this, minimize the screen. I'm going to stop my screen sharing, and I'm going to go get Gina, okay?
Okay.
All right, here we go. Hi again. All right, where's Gina? Gina, I got to figure out how to do that when, okay, invite. I'll Google it later. So, all right, so what do you guys think is the highest ion? Gina, I just invited you. I know you said you can hear me, but you're not part of the Hangout. So I just invited you, so if you can accept. Okay, so what is the highest concentration ion present if the equal volumes of acid and OH minus react? What do you guys think?
So what I had was the C2H3O2 and K+, because K+ doesn't react to anything, so it's going to be in highest concentration. And
okay. Oh, that's very good. Okay, so I think they just want for part of that reaction. Let me just look at my sheet really quick. Here we go. Okay. Oh, you are very good. Okay, keep going down. So go ahead. What else did you say, Arjun? And we'll read the solution, and I'll do screen share with you. Go ahead.
so we had K+, and then we had C2H3O2 because that's the product formed from the acid. The acid releases the H+, but that's going to be bonded and formed to water. And
Okay.
the same thing goes with the OH. So the only other ion present is going to be the C2H3O2.
Okay, very good. So let me go back to share my screen with you guys who go the answer key, okay? All right, hi. There you go. Okay, very nice. So Dennis, does that make sense to you? Let's read the solution here. The highest concentration will be the acetate ion, and of course K+, the spectator ion, okay? And as Arjun so wonderfully said, the spectator ion is slightly higher than the acetate ion since it didn't react from the potassium hydroxide. Does that make sense? Dennis?
Yep.
No.
What part doesn't make sense, honey?
Oh, why is K plus have a higher concentration?
Okay. Do you agree that K plus came from hydroxide, yes?
Yeah.
And so K plus is a spectator ion. It's slightly higher because K plus is completely soluble in water, yes? For 1 mole of KOH, 1 mole of K plus is produced. Do you agree?
Yeah.
But since this weak acid is 1 mole, they don't have the same number of moles. Do you see what I'm saying? K plus is completely soluble, so it completely ionizes in solution. Slightly, but not much. I'm sure if you put both, it's fine. As so long as you said that there was no, you didn't say that there was acetic acid and hydroxide present, correct?
Yep.
Dennis?
Uh,
You didn't
yeah.
say that there was any of these present, right? You didn't say there was any of these, right?
Yeah, there isn't any of those.
There are none of those. Okay, we're going to go on to the next one, okay? I like this question. Equal volumes of sulfurous acid and potassium hydroxide are mixed. Write the net ionic equation, okay? And again, we're going to do the highest concentration. First, let's focus on writing the net ionic equation, all right? So sulfurous acid, what do you have for the formula for sulfurous acid, Arjun?
H2SO3.
Excellent. Do you agree, Dennis, it's H2SO3 and not H2SO4?
Yeah.
Okay. Is that a strong or weak acid, you guys?
Weak.
That's a weak acid, so do we keep it together or apart?
Together.
We keep it together, okay? And then potassium hydroxide, what part of potassium hydroxide do we write down?
The OH minus.
Right. Okay, so we have H2SO3 plus OH minus. Now, when we write the products, what's going to come into play here are the molar concentrations, okay? Notice, unlike the previous problem, now they're not what?
Equal.
They're not the same, right? Who is there going to be more of in this mixture?
The OH.
Do you agree, Dennis? OH minus, there'll be twice the amount? There's twice the concentration. So if we start out with the same volumes, no matter what they are, there will be twice the amount of hydroxide.
Okay.
Yes?
Yeah.
Okay. So what does that mean then? Well, if we just speak basic moles, if we have 1 mole of H2SO3 and 1 mole of hydroxide, how many H's will come off? Will one come off or both come off?
One.
One. Do you agree, Dennis? Because 1 mole of H2SO3 produces how many moles of H plus, or contains how many moles of H plus?
2.
2. Yes, Dennis?
Yeah.
Okay. So in order to remove both of the H pluses, we need twice the number of hydroxides. Do we agree?
Right.
Okay. Do we have twice the amount of hydroxides?
Yes.
Yes. So go ahead and write the products. Now that we know we have twice the amount of hydroxides, we know that we remove both of the H pluses. Yes? Go ahead and write the products, and then you can tell me what you get. All right? I'll give Dennis a moment before we reveal the answer, because I know you already started on this, Arjun, right?
Yep.
Okay. Do you want to share with what you have, Arjun?
For the products?
Yep.
All right, cool. So for the first product, I have HSO3 minus, and the second product is, of course, going to be water.
Okay, let's talk about that. Remember we just talked we have twice the number of hydroxides?
Oh, so it diffuses both first?
Well, it takes out each one.
Oh, okay. Right, because there's twice the amount. Right.
Right.
Okay.
We just said the mole ratio is 1 to 2, and you also have the twice the moles present in the concentrations, yes?
Yep.
So those are going to be the products. Right
Okay.
now I'm more concerned that you know how to write the reactions.
Oh, yeah.
So the big difference is whether it goes to HSO3 minus or SO3 minus 2, right? Now,
Okay.
what if this said 0.15 molar, and we might see that later in the handout. What if it said 0.15 molar potassium hydroxide? Would the product change?
That makes sense. Yeah,
Yes.
it would change because it would be SO3, it would be HSO3 minus 1 because
Correct.
only one needs to be diffused.
Yes.
That makes more sense.
Yep. Dennis?
Wait, Miss Sabatello?
Yes, go ahead.
If you were titrating with this acid, would that have like 2 of the
Equivalence points, yes. And we will see that when we do our lab next week, since it's now going to be next week.
Oh, okay, so that makes more sense. So,
Yep.
so when it's a 2-to-1 ratio, then it completely releases both H's. But when it's 1-to-1, then it only releases one. Okay.
Right. Yep.
Okay.
Okay. It's all about the stoichiometry.
Okay.
Dennis, does that make sense? Oh, look at the next question. JK, look. It's almost the same thing, but it's just what we're talking about, right?
Yep.
So now the concentrations are the same, but they swap out lithium, potassium in the previous problem, and they put lithium in it. Is that going to make a difference?
Yes.
Okay, hold on. In the previous question, they had potassium.
Oh, no.
And now they have lithium hydroxide. Does that matter, you guys?
The lithium doesn't matter, no.
Right, because, Dennis, do you agree that only the hydroxide reacts?
Yeah.
Okay. Dennis, do you see in this problem now how the concentrations are equal?
Yeah.
So therefore, the products are going to be different. This is what we were just talking about. Check it out. There's only 1 mole for every 1 mole of the acid. So only 1 H plus is removed. So here 1 H plus is remaining. You see that? See that there?
Yeah. Yeah, I see that.
Okay. All right, I'll give you a second to write that one down, and then we're on to number 6. You guys are doing great. When we're finished, I'm going to try to email the solution sheet to you guys, but they attended the Hangout, but you might not be able to open it. And if you can let me know right away, because and I'll tell you what to do if you can't open it, okay?
Okay.
All right, here we go. Number 6. Ooh, I like this one. Sodium acetate and hydrochloric acid are combined. Write the net ionic equations. Let's just write the net ionic equation first. Okay? If we start with sodium acetate, which part of that compound is going to react? We know we're in the topic of acids and bases, so who's going to react? Sodium or acetate, you guys?
Acetate.
Yep, acetate. And out of hydrochloric acid, who's going to react? H plus or Cl minus?
EH.
EH plus. Yep. Go ahead, I'll give you a moment to write your net ionic equation. Okay? And we're going to do a couple other things with this reaction too, okay? Okay, you ready? So what do we have so far? Dennis, can you tell me what you have for number 6 so far?
C2H3O2 minus plus H plus yields H C2H3O2.
Can you repeat to me your product again?
HC2H3O2.
Yep, perfect. Another way they tend to write acetic acid is this. They tend to write it CH3COOH right here, but they accept either way. You know what I mean? This is the organic chemist way of writing acetic acid, as well as the ion. Makes no difference, okay?
Okay.
Do me a favor before we go on, you guys. I want you to label in this reaction the acid, the base, the conjugate acid, and the conjugate base. Go ahead and do that. Label the acid, the base, the conjugate acid, and the conjugate base. And then we'll go on. I'm going to make my daughter work with me on the ACT science later today. At least I could work with her on that part. She's got to do something, you know?
Yeah.
I'm going to tie her to the chair. All right, who's our acid, you guys, on number 6? Who did you label as the acid? Hello?
H3O.
Yes, did you label that as acid? And who's our base?
C2H3O2.
Yep.
Yeah.
And then this is the conjugate acid, and water is the conjugate
Base.
base. Are we good, Dennis? Yeah?
No.
What's the matter? Okay, you know that H3O plus has to be the acid, correct?
No.
It has to be, honey. H3O plus comes only from acid, so that has to be the acid.
Okay.
Okay? Therefore, that makes the other guy the what?
Base.
The base, right, Dennis? Yes?
Yeah.
So therefore, remember, conjugate acid-base pairs differ by 1H plus. So if H3O plus is the acid, who is its conjugate base? Which other thing in the product differs by 1H plus?
H2O.
Water, right, Dennis? Dennis?
Yeah.
Okay. All right.
Okay.
And after I'm done with this, too, feel free to go and do the whole worksheet again without looking at the answers. It's really helpful, okay? All right, let's go to 7. Okay. They're equal volumes. Okay. Also notice they're the same concentrations. Okay. What's the chemical formula for ammonia, you guys? Ammonia?
NH3.
NH3. And what part of nitric acid will react with ammonia?
Okay.
What part of nitric acid will react with ammonia, guys?
NO3 minus.
Careful. Let's go back.
Oh no, the H. The H will
Right,
react because NH3 is a base.
Nitric acid is an acid.
Yep, and NH3 is a
Plus,
base.
and ammonia is a base. Remember ammonia is a base, you guys?
Yep.
Your labs? Dennis?
Yeah.
So that all that's going to react is NH3 with H+. Okay, go ahead and take a moment to write down the reaction. Just write the reactions, all I care about for now. Okay. Okay, and then, okay, Dennis, can you tell me, excuse me, Dennis, can you tell me what you have?
NH3 minus plus H plus yields.
Wait, stop. NH3 minus? Okay. Ammonia is a neutral molecule, honey. It's just NH3. It has no charge. It's a neutral molecule. Okay. So NH3 plus what else?
H plus.
Uh-huh. And what are the products that you got?
NH4 plus.
Very good. And that's the only product, right?
Yep.
Ta-da! They put H3O plus, but that's the same thing as H plus, okay? And then if you put H plus here, then you would have no water here, okay?
Okay.
Good? All right, let's go to 8. There we go. Okay, try that one without me saying anything. I'll wait while you guys write, okay? Very similar to one we did before. Ooh. Yeah, I don't think I'll have to do that. So again, you only want to write the ions that are going to react, okay? And knowing that we're in the acid-base unit, you're going to want to find the acid and the base part of each compound, right? Yes?
Yes.
You omit the spectator ions. And after you cycle, after you know what ions are going to react, you write them down, and then you notice the molarities. The molarities will make a difference as to the products that appear. This is similar but a little different from the ones we did before. Okay? All right. Oh, who wants to give their what they have so far?
Okay, so for the reaction, I have SO3 minus 2 plus 2H plus yields H2SO3.
Great. Did you get that, Dennis?
Yeah.
Okay, let's see what they have. Again, they say 2H3O plus, so 2H plus is perfect, and then we wouldn't have any water. Okay? They're both accepted whether you say H plus or H3O plus. If we are going to say H3O plus, then you have the water. If you just say H plus, then you have no water. Right? How'd you do on that one, Dennis? Sorry?
I still don't get the H3O plus part.
Honey, did you write H plus?
Yeah.
Then that's fine. SO3 minus 2 plus 2H plus yields just H2SO3. Is that what you have?
Yeah.
Honey, H plus is the same thing as H3O plus in water. Remember they mean the same thing? Yes?
Yeah.
Okay, we're going on to number 9, okay?
Okay.
Go ahead, you guys. Can you see it okay?
Yep.
No, my screen froze.
Uh-oh.
Yeah.
Do you have another computer? Do you have the worksheet, though, Dennis?
I have the worksheet in front of me, yeah.
Okay. Next question. You said your screen froze. Are you using your Chromebook or a laptop?
My Chromebook.
Your Chromebook? Okay. And so you're using your Chromebook and it froze when we were doing this, correct?
Yeah.
Okay. No problem. But you can still hear me, right?
Yeah.
And I can hear you, and you have the problems on another computer.
Yeah.
What is the other computer you're using, by the way?
The other computer?
Yeah.
What do you mean, what am I using?
You said you're looking at the worksheet on another computer?
Yeah.
What other computer is it?
A laptop?
Yeah. So next time, why don't you do the thingy, the Hangout on your laptop, okay?
Okay.
Thank you. Keep going. What happened?
No, I just realized my reaction was a little weird.
Oh, that's funny. How do you know your reaction's weird?
I wrote it incorrectly.
Okay, let's start with the reactants, okay? What do you first have for the reactants, Arjun?
So it's CO3 minus 2.
Uh-huh.
And it's going to be plus H plus.
Okay, keep going.
And then it's going to yield HCO3 minus.
Very good. That's correct. So why is it weird?
What I had earlier was the 2H pluses.
Okay,
but
good.
that doesn't work because it's only 1.1 molar of each.
Very good. Okay. But wait a minute. But sulfuric acid has how many H pluses?
2.
Yes.
Oh, so I was right in the first place.
Yes.
Okay. Oops.
Do you see that 0.1 molar sulfuric acid yields 0.2 moles of H plus?
Yes, because it has 2 H's in the first place.
Yeah.
So it still works. Okay.
So therefore, they're tricky, right?
Yeah.
Although this is weird that they, hold on, because doesn't it, I think they're wrong in this answer key, and I could write them, hold on. They're saying to go to only 1, but I think it would be 2 because you have 2 moles. They're wrong.
No, you're right. You would have 2.
Right. Yeah, they're wrong, right?
Hmm.
So let's see if I can write on this. Dennis, I can't write on this, I think. Well, let me see. Tools. Maybe I can make comments on it. Let me see. Watch me freeze your computer. Oh, yeah, you can't see my screen anyway, right? It froze. Dennis?
Yeah.
So you should have CO3 minus 2 plus 2H plus yields H2CO3, correct?
Yeah.
Okay. We're going to go to number 10 now. Notice in number 10 that it says solid, right?
Yep.
So even though sodium fluoride always dissolves, we should leave sodium fluoride together and not separate it yet, right?
Yep.
Okay. I'll give you a moment to do that one. I'm going to grab paper while we're doing this because I'm going to jot down some things for another thing. See if paper anywhere. Okay, are we ready?
Almost.
Almost. Okay, so give it a whirl. Else, I guess, looking. Okay. So the reactants, again, you're going to have NaF, but we need to include what?
Water.
Water. What do you guys know from this unit? Is it going to make an acidic or basic solution or neutral?
Well, Na is the counter ion of like NaOH, and then F is the
No,
counter
no,
ion.
no. I wouldn't think of that. Na is just a spectator ion. Group 1 ions are never, ever acidic or basic.
Right, they're neutral.
Yeah, right. Don't think that it's counter of NaOH, you know, because that'll confuse you. Group 1 ions are always neutral. But what about sodium fluoride? You guys should know sodium fluoride. What does sodium fluoride contain? We already know sodium doesn't affect the pH. So what about F minus?
Oh, so let's.
Sorry? What is F minus? What is it related to? Is it the conjugate of something?
The conjugate base.
H plus or HF.
Conjugate base of?
HF.
HF. Is HF a strong or weak acid?
It's a weak acid.
Yes. Okay.
So it would be weakly acidic.
So it'll be what?
It would be acidic in solution.
Hold on. F minus. What is it?
Oh, it's the conjugate base, so it'd be basic in solution.
Thank you. That's always right on paper first, okay?
Yes.
So, do you gentlemen agree that F minus, the solution will be basic? Yes or no? We got to do that first.
Yes.
Yeah.
Dennis, I can't hear you.
Yes.
Okay. So therefore, in the products, what does a base do? Does a base donate a proton or accept a proton?
Accepts protons.
Accept a proton. So what must one of the products be? F minus is a conjugate base. So what is it going to become in the product?
HF.
HF. Now, we cannot destroy matter. So what must be one of the other products?
NaO.
What? I can't hear you.
NaOH.
Do we write it together?
No.
Why not?
Because they're soluble.
Yes, and more importantly, NaOH is a strong base. So how would we present? Yes, we need to have Na in the product so we don't destroy matter. So how do we write that in the products? Na what?
Plus.
Yes. And then we know that it produces a basic solution. So what else must be in the products?
OH minus.
Perfect. Guys, put it all together and see what you got. See it at the bottom of the screen?
Yep.
Okay. So how are we doing so far? Ready to do a couple more? Dennis, Arjun, you ready to do a couple more?
Yeah.
Okay. Go ahead, do number 11. I'm scrolling down some questions for later. Okay. 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 So Did you guys identify the ions that are going to react from each compound? Let's try it. So out of ammonium nitrate, which one of those are going to react? Ammonium or nitrate?
Ammonium.
Ammonium. Do you agree, Dennis?
Yeah.
Okay, because nitrate won't affect the pH because it's the conjugate base of a strong acid, right? So ammonium, what's the chemical formula of ammonium that you wrote on in the paper?
NH4.
Plus.
It has a charge, right, Arjun?
NH4 plus, yes.
Yes, yes. Dennis nicely added in there for you. Thanks, Dennis.
Thanks, Dennis.
And then out of sodium cyanide, gentlemen, which one is going to react, sodium or cyanide?
Cyanide.
Yup. Now, who's the acid and who's the base?
NH4 is the acid. And
Yup.
CN is the base.
Cn minus is the base. Yes, so go ahead and write the product. And we'll look at it, okay? Okay. Okay, here we go. So, ready? What you get for the product? What you guys write for the product? You want to tell me, Dennis? Dennis?
I got NH4CN.
What do you guys think? NH4CN? Okay.
I had NH3.
Hold on, wait. Don't say anything yet, Arjun. Wait. Okay,
What's
hold on.
this?
Not yet. Dennis, you already told me that cyanide's a base and ammonium is an acid. Going back to the beginning of the acid-base unit, Bronsted acids and Bronsted bases do what with their protons? What does a Bronsted acid do?
Donate.
Donates a what?
Proton.
Yes, who's it going to donate a proton to?
CN.
Yes, Cn minus. Okay, you want to fix your products, Dennis?
Yeah.
And here's how else you know that the product is not NH4Cn. Dennis, in a net ionic equation, you can't write NH4Cn together because what do you know about compounds in solution that contain ammonium?
They're soluble.
They're soluble, right. So you will never see NH4Cn written together as a product in a net ionic equation, okay, if it's aqueous. So also you didn't apply the acid-base theories where the acid donates a proton and the base accepts a proton, okay? All right, so go ahead. Do you have the product yet, Dennis?
NH3 plus HCN.
Yeah, perfect. That's it. Is that what you have, Arjun?
Yep. I had those products.
Great. We're going to skip 12 because it's very similar to what we had before. Let's try number 13. Go ahead and do 13. Okay. Okay, let me know when you guys are ready, okay?
What are we trying to solve for 13?
Sorry?
What are we trying to find for 13?
The reaction, honey. You want the net ionic equation.
Okay.
These are all net ionic equations, Sonny. Okay. Oh, how could my thing have low battery? That's all right. We have 7 minutes remaining. All right, are we almost ready?
Yeah.
Okay. Okay. Okay, so Dennis, Arjun, let's hear what you have.
All right, cool. So I have H plus
Uh-huh.
plus F minus
Okay, let's wait. Why did you put H plus?
because the NAF is going to have the F minus act as a base.
Yes,
So
but
I thought.
where's the H plus coming from, sweetheart?
Oh, sorry. It's coming from HC2H3O2, the acetic acid.
So how do we write acetic acid when it's in a net ionic equation? Do we put it together or separate?
Together, right, because it's a weak acid.
Yes. Dennis, did you keep acetic acid together?
No.
Did you write HC2H3O2 in the reactants?
No.
What did you write? H plus?
Yeah.
Okay. Can you guys label that as a weak acid on your paper and write always keep weak acids together, okay?
Okay.
Take a moment to fix your reaction and we'll end with this one, all right?
Okay. Okay.
Uh-oh, I gotta plug in really quick, okay? And then we'll wrap up with that one, okay?
Okay.
I just don't want to lose you in the middle. I have my plug right here. Where'd it go? Oh, it reaches my wall. Okay, are we ready?
Yeah.
All right, Dennis, want to read me your products now?
HC2H3O2 plus F minus yields HF plus C2H3O2 minus.
That's
Yep.
perfect. How'd you do, Arjun? This is it.
Yep, I got the same thing.
Yeah, and they write the formula for acetic acid and acetate a little bit differently, okay? So let me just see if there's any that you should skip. I think they're all pretty good. 4-2 would be good. Ooh, these are really good. You should do the rest of it if you get a chance and email. I'm going to try to email you the answers, or you could email me your answers. So what I'm going to do now is try to email you the rest of the answer sheet. But if it doesn't, you can't open it because it asks for a digitally encrypted ID or whatever. You can just email me pictures of your work, and I can check your answers if you like. Okay?
Okay.
Yep.
All right, so thank you for attending today. I hope you guys stay warm, and I hope we have school tomorrow, okay?
Okay.
If not, stay tuned. Maybe we'll do another session on the rest of the handout.
Miss Sabtella,
Yes.
our lab is still due tomorrow, right?
Yep.
All right, cool.
Yep. We're not. Yeah, that way I can check your setups while you're doing the quiz.
All right, cool.
I'll make a posting. Okay?
Okay.
On the community.
Thank you.
All right, bye guys. If there's no school tomorrow, I'll do another one tomorrow. Okay?
Okay.
Bye. Thanks for attending.
Bye.
Have a good day. Stay warm. Bye, Dennis. Bye, Gina. If you're still there. Bye.
Bye.
Oh, wait, you were here. You never said
Yeah,
anything.
I was listening.
Oh, honey, but next time participation is how you really get to really understand the information, okay? But thank
All
you.
right.
Okay? Thank
Okay.
you very much. Bye.
Bye.